This is the second part concerning integration. We are integrating various providers in the cloud for artificial intelligence, in particular for GeneXus 16, IBM Watson, Cognitive Services, SAP Leonardo, and then next Google Cloud Services. And also the Amazon Web Services in the future. We're going to try to do things that are more oriented to the offline part, models that don't have to consume from the cloud. What are we working on? We are working on an API, especially with these providers, so as not to have to learn solutions in particular, just Microsoft or SAP solutions. And now we have a built-in module in GeneXus. We go with Knowledge Manager, then Knowledge Manage Reference, and there's GeneXus. These are the built-in modules. So you click on the install button, and then you get it integrated already in your knowledge base. And here you see also GeneXus Core and other things that are already defined. Let me add that all this is in the wiki. There's a talk on this topic that is quite complete, and we are going to continue working on it. How is this module structured? It has 4 submodules. I'll tell you what each one does, and then a series of domains and type of data that are going to help us with the input and the output of the methods. The modules are quite intuitive. This confidence is the level of confidence that the provider sends back to us, and then core between 0 and 1, and the semantics of the score depends on the method we use. Label, text. This is more particular than language. In language, it could be the Spanish of Spain versus the Spanish of Mexico. Same thing for English, US or British English, etc. Type of data. We have first this structure and the label that concerns the confidence. The model tells us what's the level of confidence, and then distributions that also has 2 labels, but it's also going to give us a region. Basically, what it gives us is top, left, width, and height. What's this? Well, in order to draw a rectangle, we define the top. This would be the height, the width, and we can draw this rectangle on an image. And these are metadata, additional information that the provider returns to us. The first module we are going to talk about is configuration, and this is very important because it's common to all. We have SSDT, where we can configure the properties for our provider with the name of the service that we are going to use, the type of provider, and then several properties that we are going to configure. What type of provider? Well, this is a number domain where we're going to have all the providers that we are going to support. As I said, we have Microsoft, IBM, and SAP, but then we are going to add others. And how do we program it? We have a provider. Here we set the name. We are going to use a text-to-speech. This is Watson acronym, then provider type, in this case IBM, and this is very important. Each service has its own configuration of properties. For example, the text-to-speech requires to use a username and password to have access to the service, and that's what we do next. We create a property. We tell them that this is a usernet, and then we add it to the other set of properties for that provider, and then the power. With that configuration, we have everything. This is the property key that is going to define the properties that are available. Key when it's an API key, username, password, usually done simultaneously, and then we are going to see the identifier of the deploy when we have the custom models, not the default that each provider supplies. Then this is the interesting part. Two procedures here, speech to text, which gives an audio. Let's see if I have the pointer. I have an audio, and I tell the locate where this audio would be. It could be the specific case of the Spanish from Spain, then the SAP provider, and this to handle the errors that the system can return, a parameter, a configuration, etc. The interesting thing is that on the basis of this audio we get the plain text of what is being said. We have the text to speech, which has additional parameters like male or female voice, and these last two parameters are common to all of the methods that we may find in GeneXus. Then image module, we have methods like classify. Given an image, it's going to return a series of labels and their probability. We had seen this in SDT. Opus label, the label in itself, and secondly the confidence. And this gives us a collection, an image and a collection of labels with probabilities of what can be identified. These two parameters are always kept because they have many functionalities. Then we have detect faces, which gives an image, recognizes faces, and gives us the regions of these faces. With the SDT, we mentioned previously, detect objects, detect scene, that gives us a sequence of labels in an image, labels that it's complicated to distinguish this one from the classify. Detect scene, for example, if I take a photo in the Eiffel Tower, Opus label will tell me you are in Paris, etc. Whereas the classify tells me what things appear in the photo. Then, for those who don't know this acronym, it means optical character recognition. Given the text in an image, we can also indicate the language in which this text has been written. Then I go to the regions to see where these texts are located, and with this we finish the module. And finally, we have primitives to detect the language. There's just one label. This should be singular, not plural. It returns a language, a level of confidence. Excuse me, coming back to the previous one, OCR, did you say it returns the regions, not the text? Yes, but remember that the SDT Opus region has a label and the level of confidence that that word is that one, and then where it is located. That is what we said, top left with height. Where does it return it? In this SDT. Afterwards, we're going to see an example to clarify this. So we are here, detect languages, detect entity. It tells us which entities appear in this text. For example, the name of a person, organization, country, things that we can bring to this text, and it gives us a sequence of labels. Then key phrases and even keywords. If I have a more limited set, it's a collection of labels, and each label represents a phrase. And then an analysis of the sentiments, where an opinion is positive or negative, and this score goes from 0 to 1. In this case, 0. I'm rushing. I have a doubt. All the results I obtain will depend on the provider, right? Yes. Each one can have a different provider, because a provider may be stronger with regard to the text, another one with regard to the image. Yes, you can use sentiment analysis for Microsoft and another one for IBM. The only thing that you do is to configure the provider for that case. They can coexist. Yes, it depends on how you codify this. When you send the parameter, you said whether it's with Microsoft or IBM, etc. And you can alternate them. The question of score. This is a score between 0 and 1. When it's closer to 0, it's more negative, and more positive if it's closer to 1. And finally, the typical translate from one language to the other. It gives a source language and a target language, and it gives us the translated text. Then provide a message that we configure. Now the proof of concept, which relates to your question. We are going to select an image from the gallery, a face, first button to detect faces, and we can draw this region. I'm just changing the metadata that the server brought. And the second case, we apply the OCR, and this is what I was telling you about. It's going to return the region and even the text that I identified. How is this panel designed? We have a canvas and the two buttons that appear as floating, and we have a grid that is an image map. This SD allows me to draw the upper corner, then the left corner, the X and Y. In this case, it's just square, not rectangles, but we're going to improve this later. And here we have the event when I press this button. When we have the image, we call the method, and we do a reload of this grid. The reload has to do with the control, and maybe it's not for the presentation, but I'm going to tell you about it anyway. And for the case of CR, I apply CR on the image. The source language is English, and we do reload. What is this reload? As I said, this grid allows me to set an image as a background to this grid. I set the image as background in the grid, and here I do a transformation. If I transform the rectangles that these solutions return and transform them into squares, as I said today, well, for the time being, we have this limitation. In the web, it's so flexible. You can draw rectangles with the user controls. So this would be the end, but I see you have a question.
Supongamos que quisiera hacer un chatbot.
Let's assume I wanted to do a chatbot. Could we use the speech to text? And that would be within the SD panel of the chat? Yes. When I capture the voice, what do I do? Do I save it in a file and then I put the file in the speech to text? Yes, it's an audio variable. Let's go back. This is an audio variable. If you are in SD, for example, you remember you have the audio recorder. You do the recording and you save it in this variable. And this variable is the one that you pass on to the service and it returns the text. And that's enough.
If I've got, for example, a model that I've created and trained with images, how do I configure that there? Because I think you're using we are using the default models. We're thinking of incorporating, but what you're saying about it is something that providers are incorporating. I think Microsoft is. I don't know about the others, but we haven't got a mechanism to include it. But most certainly you'll have it soon, and that's why I said when I talked about the properties, I said we're going to have information about where you have deployed that model. In that case, you can use it. So you can't train a model at present. Well, with the release we've got right now, version 16, you can't. No. Let me add something here. This is the first version of the AI module. We're going to continue incorporating models for local providers to run the device, and most certainly we'll have the possibility of using TensorFlow or any other language. We are taking our first steps in this. What we added were the most basic functionalities, but the idea is to move on. We can't really, we haven't defined everything yet, but the idea is to continue working and to continue incorporating functionalities.